Welcome back all of you for the UGC lecture series on lasers and their applications and the Swayam portal. In the last lecture, I was telling you something about radio broadcasting, point to point telephone communication using audio wave and radio wave frequencies. Remember, all these were up to audio wave, radio wave. For example, for telecommunication, we had communication only with the electrical wires. Remember, electrical wire brought the communication. It is not electromagnetic wave which brought the communication for ordinary telephone communication. For broadcast, radio wave, electromagnetic wave was the main carrier. The usual frequency was in few thousand hertz or up to I would say 100 kilohertz. Then when you wanted to jump to visual communication, video communication, we required a big bandwidth as a carrier, bandwidth, I mean variety of signal has to be coded onto this one. So things became complicated. It took a lot of time for television broadcasting. For example, if I remember correctly, the first radio broadcast in Chennai was around, you can say 1022 or 1024, and first television communication was in 1964. That means almost for 40 years we were living only with the radio communication, radio broadcast. It took 40 years for us to jump from audio message to video message. That's first step. After that, when we jumped into video messages, and then technology improved, and you could have seen that a special kind of wire came to your house, that is called the cable. That cable brought a new type of message, that is a microwave signals could be brought through these cables, and they were fed into a TV, and then you were able to see so many programs in cinemas. In between there were so many changes, very high frequency, high fidelity frequency, there were so many improvements. All those things were slowly forgotten, because microwave, when we jumped to microwave, we were able to have a big feast of video images plus audio images. All these were established, let us say, from 1964. Then it took a lot of time for jumping from TV, which is a broadcast, to smartphones, phones and smartphones. What is the difference between TV and smartphones? In a TV, in some station, certain program, audio plus video program will be shot. Then it will be uploaded in certain carrier wave. That carrier wave is broadcast throughout the world. Whoever can tune to that particular frequency, I would say whoever can catch that particular frequency can bring home and try to kick out the messenger and take the message. That is how a TV signal happen. Anybody who is nearby me, simultaneously hundreds of people, thousands of people can see the message, the video and audio message. It was not point to point. Then it took a lot of time. Now, with the smartphones available in 2010 on, I can have a smartphone, I can take a motion picture of me, I can dance, I can sing, I can cry, I can do all stupid things before my smartphone. That's all. Click the button, this will go to my son, and my son or grands will laugh at me. This is point to point audio plus video communication between two set of people separated by a distance of few thousands of miles. That is just possible just by the click of a or a touch of a button now. Technology has improved so high, and that is what we are going to see how. For this, we went on to microwave and light wave. Microwave means the frequency would be about 10 power 9 hertz or 10 hertz or 11, not more. So, we say it is about gigahertz frequencies, megahertz or gigahertz range. The microwaves have a short wavelength. Since it is a short wavelength, when it comes out from a microwave antenna, antenna is the one which releases the microwave. The microwave antenna will release it, and whatever wave comes out will be just a cone of a diameter of about 10 centimeter or 20 centimeter. That means it will be directional. So, I can have a microwave antenna direct towards the like this, and this will go to a tower. Not only that, that tower can send back another microwave something similar to this one. So, that I have a big disc of a diameter of about 1 meter the diameter, which will be a concave reflecting metal, which will capture the microwave and focus on to some small device which is capable of capturing all the microwave signal, carrying on through the cable to some device inside even your TV, which will again kick back the microwave, take the message alone. This is how done. What is important here is all the microwaves are mostly directional. They can connect up 2 or 3 or 10 well defined points, not everywhere. It cannot do broadcasting like radio wave or audio waves. Now, one such picture is shown here. In the picture you see on the surface of the earth, there are 2 towers. I send a microwave image, I send a microwave carrier to another tower. It is a point to point, it is not going beyond that one. Nobody else is catching it. Look at this one, it is a point to point communication between 2 towers employing microwave. Or if I want, I can tilt it and send it to the satellite also. Then when it reaches the satellite, which is kept at the height of about 100 miles, remember only about 100 miles, that is the range where all the geostationary antennas are there. Communication satellites are not in 10 kilometer or 5 kilometer, way above. So, that below that up to 30 kilometers or 40 kilometers, you will have the channel for flights. The flights are going from half a kilometer to 30 or 35 kilometer height, not beyond. Whereas, these antennas are about 50 kilometer or 60 kilometer and above. They may be, most of them will be geostationary. Geostationary means they will be rotating along with the earth's movement. So, if I have a geostationary just above my head at a height of about 100 kilometer, it will be moving along with me. So, I can keep on directly sending the message. That is advantage. That is the idea of geostationary orbit satellite. So, in that way I can send the message. Then now, why do we go for microwave? Microwave has a frequency of about 10 power 9 hertz. For one particular channel, audio plus video, we need at least, you can see this one, 2 megabits. Mega means 10 power 6, bits per second means instead of 2 megahertz, I can convert the frequency into bits per second. That is all that I do is convert every positive signal. See, if the wave is going up, I will say 1. When it is negative 0, another one 1. Like that I can quantize it. So, I can convert easily a megahertz electromagnetic signal into megahertz bits per second. I do digitalization. Okay, then with microwave at 2 gigahertz per second carrier capacity, I can easily accommodate 100 channels. That is advantage. Then this was the time where we were employing variety of TV programs up to, let us say, about 20 years ago. Then at those times, if you remember correctly, or I do not know whether some of you may have experience or may not have experience, suppose I try to download a TV program from one of the stations in India. After some time it will stop. It will say, it will keep on going in circle and circle. It will say, wait for some time, I need certain time to download whatever message you want. In a similar fashion, few years ago, when I used to call my sons in USA, there will be a bell ringing, and then I will get a message saying that all the lines are busy, call after some time. This is because so many people are trying to call some relations, some friends elsewhere. So, there was a total traffic jam of signal, something very similar to traffic jam of auto rickshaws and cars and cycles in Mount Road. The road is the same, but if there are too many cars, you will have a traffic jam, particularly after 6 o'clock, because everybody will be coming out of office, total traffic jam. That was the situation about 20 years ago. Then next question, how do you overcome this one? You cannot stop the people buying a car, you cannot stop the people buying a motorbike, you cannot stop the people walking or using auto rickshaws, because people are growing in population and they need some kind of vehicles to move from one place to another. So, the only possible way is make a big road. Then it is possible to allow all the vehicles. What is the best way? Very good, make a bigger road, say 4-track or 6-track road. Let us say from Chennai to Madurai, you have a 6-track road on left side or right side. Then in each one you define, you make a line, you can say this is the road which is meant for heavy truck, they will go very slow. Then there are roads for very fast cars, they want to go for a long distance without any stop, and there are certain ways for bus stops. So, you define all the tracks. Once you have defined this one, and if you have broad one, the things will go without anyway getting stuck. This is exactly what people have done, employing a big road. That big road is a laser. Most important laser is the infrared laser. Let us imagine that we are employing a laser of 1000 nanometers. For simplicity, I have given this one. This is equivalent to 3 into 10 power 8 exponential 8, not 3 times 10 power 8. That is a speed of light divided by 1000 nanometer in terms of wavelength would be 10 exponential minus 6, that is a meter. Now, multiply from this, you will get what is the frequency of the laser. The frequency of the laser is 3 exponential 10 power 14. That means, this is about 303 into 10 power 14 hertz, that is the frequency. That means, the bit rate will be approximately 3 into 10 power 14 bits per second. That means, it is a very big road. Now, look at this one. For one signal, I need 2 megabits, and I have a big road. with 3 into 10 power 14 bits per second. That is, the carrier can accommodate, I have given an example, the carrier can accommodate easily 20,000 customers watching the same movie simultaneously, and this is what you mean by steaming hot. This is what is being done. I can give a typical example. When a very famous movie Ponniyin Selvan was released in Tamil Nadu, people were so enthusiastic to see on the day of release in OTT on the movie platform, and then everybody was kept ready. Then when they switched on, I would expect at least 1 or 2 million people throughout the world would have had the opportunity to see simultaneously such a beautiful movie. All this because people have used infrared laser for, we have used a carrier wave, electromagnetic wave at a frequency of 3 into 10 power 14 hertz as a carrier wave. Then what is a medium which will take this one? You cannot use this laser in open air. You can use, but it will get wasted away in a short time. It cannot go beyond. It cannot go beyond few meters. It will go as a directional beam because it is a laser, but it will go a distance. If it is a infrared laser, if it is a night and if the power is very high, it can be seen at a distance of about, let us say, 1 kilometer, not beyond. So, after that what will you do? To do that, the best way is this one. You can employ optical fiber to carry the laser beam for a very, very long distance. Remember, as the wavelength decreases, when the light comes out or electromagnetic wave comes out from the source, the wavelength determines the angle of divergence by diffraction effect. It will be about, let us say, lambda. Now, for a microwave, the wavelength will be about, let us say, 1 centimeter. Then the light will start diverging like this with a diameter typically of 1 centimeter. For a light, it is about nanometer, it is about micrometer. Micrometer means the beam will come out as a beam of 1 millimeter diameter. Then automatically you should think of an optical fiber. An optical fiber is capable of carrying this one. Optical fiber has a thickness of about 1 millimeter or even less. You must make use of this idea of light acting as a carrier of message, and this should be the channel through which it can be moved from one place to another. Is the best way is optical fiber. Then, as I told you sometime earlier, the infrared diode laser and the optical fiber are something like made for each other. Optical fiber has the best use in optical communication, and infrared laser has the best use for, again, to be launched into the optical fiber. In that way, it is made for each other. Now, if it is coherent, you can use this optical fiber for carrying ordinary light, not necessarily a laser light, because it is important to know optical fiber has been used even before the laser came into the picture. Endoscopy is a device which the doctors used to employ for variety of observation, diagnostic, understanding of what is happening inside the mouth. They put an optical fiber, allow it up, go to intestine or the lungs or whatever it is. They would take a picture. It is something like a close X-ray. They would have better information about what is happening inside the body. Sometimes they used to send a powerful light through the optical fiber and do certain surgery also. they were all primitive at the beginning, but once the laser came in, biggest advantage is you use a high power laser launched through the optical fiber. At the end of the optical fiber have a small lens. The lens will focus all the laser beam on a spot. Then you can do a specialized specific laser surgery and cut off a certain small lesion or remove the tissue, unwanted growth. This is what they called laser surgery, which is a big success, which is a very important medical advantage, medical application, about which already I have spoken about it. Now, what is important right now is this kind of particular laser acting as a messenger, it has become possible because of optical fiber. What is this optical fiber? I can give an example here. Now, look at this diagram. You start with a message on the left side. You just change the voice or your optical information, modulate on the LED, light emitting diode, or LD, both are possible. Light emitting diode is a diode which emits light, not a laser. LD is a laser diode. Both are being used these days depending upon the situation. Now, when you have a small lens, focus onto the optical fiber. The optical fiber has a special type. It has a core and a cladding. Core is a glass. Let us take it is a glass of refractive index, let us say 1.5. On the outside, you will have another type of glass of refractive index, let us say 1.3. Inside is 1.5. So, refractive index inside is greater than the cladding. Under that condition, when the angle of incidence is greater than the critical angle for the two media, one is a core 1.5, cladding is 1.3. So, if you look at calculate, then when the angle is greater than the critical angle, which you must study in the school, you will experience total internal reflection. Light will not go out, it will be reflected inside. So, in that way light will go a zigzag path undergoing total internal reflection. If the optical fiber is really good in quality without any kind of inhomogeneities, then if we have sent 100 photons this side over a distance of 1 kilometer, you may get about almost 90 photons. You will lose only about 10 photons, provided the optical fiber is pure and without any inhomogeneities, without any other flaws, crack or anything. These are all specially prepared material. Such materials are available. Eventually, at the far end, you put a lens, put it on a photo diode or a photo multiplier tube or any photo sensor, photo detecting device, which will capture the light. The light has the light plus modulated signal. Remember, the light is just like a postman. Once it goes to the photomultiplier, the photomultiplier or a photosensor will detect the light with its variation. It will be amplified, then it will be detected. There will be something to filter and kick out the light, and what you finally get out, and that will be your speaker or your video CCD camera or whatever it is. So, it will capture the video image as well as audio signal. That is how the whole process is working as a laser plus optical fiber. These two put together have done great wonder, and you can see the same thing I have explained in the top also. Source, in the top picture you can see source is the laser, information, it may be audio or video, both put together do the modulation. Then in between you can have air as a medium, or you can have optical fiber as the carrier or the road, then send it across one satellite to another satellite, one tower to another satellite, or one place to another place through optical fiber. All are possible. At the other end, you have a receiver, demodulator. Demodulator means removing or kicking out the messenger, the postman, and eventually you will get the information. That is all the whole system. Now, look at the point. Since you can put optical fiber, bunch of optical fibers, you can have enormous number of communication. Next point is, optical fiber is very good insulator. So, whatever information is sent will not be leaked out. So, the secrecy is maintained. Not only that, extraneous signal will not enter here. So, you will get a pure signal output at the end. That is the biggest advantage. Based on all this, the modern technology has come up such a great level that I skip all this method of pulse code modulation, which I have already explained. I will show you some of the big systems. I mean, this is the typical example of pulse code modulation, about which already I have mentioned. Particularly these days, we have a mode locking laser pulse. Mode locking laser pulse means you will get a train of pulse, each of time duration about 100 picosecond with a pulse duration of 1 microsecond. You can imagine such a train of pulses. They can be very easily modulated, and any kind of signal can be converted into quantized digital signal, and one such thing is shown at the bottom. Whole of laser communication system has been shown here. What is important is, these days this is the typical optical fiber network. You have a big computer which connects a number of optical fiber, receiving and transmitting. You have the transmitting towers, somewhere you will have an antenna. All these put together work out. Right now, today in Chennai or any other big cities employ optical fiber network between two buildings, between two offices, between one place to antenna, between one place to tower. All possibilities are available, and that is next important thing is, most important thing is, intercontinental optical fiber network also I have shown. What I am trying to show is, from Chennai you have an optical fiber going up to USA by set of a number of optical fiber amplifier, optical fiber amplifier is one such network. This is undersea optical fiber network. You can see a big tube. This is very properly covered material, in which inside which you will have this kind of combination. You have a metal, inside you have a thick sheet, and then you have number of protecting material, and then you will have inner core. The inner core will carry few hundred optical fibers. One such thing is here. Now, that means all put together it becomes a big road, heavy, a very broad communication road between India and USA, going not in the sea, going under the water. This is the underwater optical communication channel which is being used these days, and all the principle I have explained. And because of the big advantage of laser, optical fiber and computer technology, we are able to see a large number of people getting educated, a large number of people getting employed. Both are possible after this 5G, and one such a thing is very often appreciated by economists. Yes, this is one. See, you can see how the 5G will enhance the socio-economic satisfaction. Everybody can get everything, every information, every knowledge, every opportunity becomes possible because of 5G, which employs laser communication systems. Thank you very much.